Hello and welcome back to CS with Mr. G. We are currently in Unit 3 of the iGCSE Computer Science syllabus, currently looking at hardware and all of the components within a computer system and devices that we see around the world. Today follows on from the input and output devices that we were looking at in the last couple of lessons, where we will look at sensors and how these apply to computer science, looking at where they exist within computer systems and where they are used in day-to-day applications, and also how sensors play a huge role when it comes to the input, process and output of data in a computer system. So I've briefly mentioned in the previous lessons that sensors fall into the category of input devices. This bit in the middle is done by the CPU or the microprocessor, and the outputs can be completed in many different ways depending on the scenario, depending on the system, and today we will look at just that, looking at all the sensors that we need to know for the syllabus. As you can see, there are quite a lot, so what we will do in today's lesson is look at each one, looking at the basics of how they work, and then real-world examples of where you would find these sensors in real-life systems. Firstly, we need to look at what a sensor is, and the definition of a sensor, which mainly comes back to this term analog, which again we've discussed in previous lessons. This process of analog to digital data, as we know, is done by many different input devices. Now when it comes to a sensor, these inputs are generally environments or real-world things that we can measure using many different tools or devices. So a perfect example, this thermometer you can see on the right here is an analog way of measuring the temperature. The red line in the middle goes up the hotter it gets and goes down the cooler it gets. There is absolutely no digital data involved with this thermometer. Likewise with these set of scales here, as you probably know, when you put an item into the scales, this red needle will go around and tell you how much something weighs. Again, it's purely analog, there is no digital data involved whatsoever. Now as you know, we can certainly measure weight and temperature digitally, and that's where sensors come in. So the term sensor means a hardware device that can take measurements from physical properties. As we've just mentioned, temperature or pressure in these two examples here. If we had a sensor, we would be taking the exact same information but in a digital format, or in other words, in binary, to be stored electronically. So the sensor is the device that takes this real world property and converts it into some kind of digital measure. And this digital measure will need to be in a number, because as we know, the computer can only understand binary, and binary is a number system. So taking that real world property and converting it into numbers is what sensors do. So now we'll go through each sensor, looking at how they work and then examples of where they will be used in real life. The first one we'll look at is the temperature sensor, and as we've already discussed, the thermometer tells us how hot or cold something is. Now a temperature sensor does the same thing, but if we use that in a bigger system, it could be used to monitor the temperature inside of a car and then do something about it if it gets too hot or cold. So a perfect example, if your car has one of these buttons here with the automatic setting for your air conditioning, the temperature sensor will detect how hot or cold it is inside your car and then turn on your air conditioning accordingly. Again, it's dealing with numbers, and when the number is too high or too low, the air conditioning will change accordingly. The microprocessor will be running lines of code in order to process this data and then turn on the fans or turn off the fans, whatever the temperature might be. So this whole process is going to be very similar for all sensors, but just in different scenarios using different types of sensors. Next we have a pressure sensor, and another perfect example is from a car, and here you can see the tyre pressure in the car is constantly measured by a pressure sensor telling the driver how much air pressure is inside the tyre. This is just one example. Pressure sensors can be used in many different ways. For example, simply detecting the touch of something, as in the physical press of a button, could also be classed as a pressure sensor. But again, the pressure sensor will detect the pressure and then do something about it by alerting the user or turning something on. But again, in a bigger system, the sensor will pick the data up and do something about it. Next, we have a proximity sensor. And as you can see, most modern cars now, that when you put into reverse, will detect if something is nearby. Now how this works is it sends out an ultrasound wave from the car, and this ultrasound wave will bounce back and tell the car how far away something is. If you've ever looked closely on your car, you'll see these little circles, and these circles are the devices that emit the ultrasound wave and detect the time it takes to come back. Again, a microprocessor would pick up this information, it would know something is less than 1 meter away, and it would alert the driver in the form of a sound or a warning light on their dashboard. But again, it would do something about it, and the proximity sensor can also be used in many different ways. An accelerometer measures the acceleration of an object and can determine which direction it's moving in. So a perfect example for this is when you tilt your phone to watch a video in landscape, the accelerometer will pick up that the phone has moved and turn your video into horizontal, filling the whole screen. Some of you may be aware that some game controllers also have accelerometers, such as the Switch or even the PlayStation and Xbox, and you can tilt the controller in 3 different axes and you can control characters or even turn a car. But again, an accelerometer will determine the rotation of a device. Next, we have a moisture sensor, and as you can guess, this will detect moisture in a certain area, such as soil, or even inside of a tumble dryer, and what it will do is it will detect for moisture in terms of water particles and then can subsequently do something about it. So 2 perfect examples. If it's in soil and it detects that soil is too dry, it can turn on an irrigation system and start to water the plants. Or if it was in a tumble dryer and that clothes are still damp, it can turn on and continue to dry the clothes until that moisture sensor says otherwise. So clues in the name, as it is for most of the sensors. Very similar to a moisture sensor, a humidity sensor will detect the humidity in the air. And again, humidity is water molecules in the air, and a sensor will determine the humidity levels of the air that it's in. A couple of examples here. In a greenhouse, again, measuring the humidity for plants, or even in your home. And if your home becomes too humid, a dehumidifier could turn on and start to dehumidify the air. Again, the humidity sensor would continue to check the humidity, and once it's at an okay level, it could turn off the dehumidifier, but then continue to check, making sure it stays at a reasonable level. Next up is a level sensor, and sometimes my students can get confused with this one, but all it does is measures the level of liquid in some kind of container. So for example, in a car petrol tank, this sensor would sit in the fuel, this arm here would move up and down, and that will determine how much fuel is in the tank. So although this seems pretty analog, this would send a signal to a microprocessor. This could display an alert on your dashboard, it could play a sound in your car, but again the sensor would pick up this information and then do something about it. A light sensor, nice and easy, will just determine how much light is around the sensor. It can sense certain light levels, not just on or off. Another perfect example from a car is when you're driving through a tunnel and your lights instantly come on. This is because the light sensor detects that it's gone dark and automatically switches your lights on for you. But light sensors can be used in many different scenarios. Even street lights use light sensors nowadays. Open and closing blinds in a greenhouse, another example. But as you can imagine, light sensor, clues in the name, determines how much light the sensor has around it. An infrared sensor sends out a beam of infrared and can determine if that beam is broken or if something interrupts that beam, and again we'll do something about it. Here an example could be an alarm system. You might have seen one of these in the corner of your house or even your school. When the alarm is switched on, this device sends out an infrared signal, and if that signal is broken or it picks something up, it would sound the alarm and the sensor has done its job. Another example is a car windscreen wiper. So when it starts to rain, an infrared sensor can detect rain hitting the windscreen. Just think of the alarm system. This is the easiest one to think of. Okay, there are 5 more to look at. We've got a flow sensor, and a flow sensor will pick up the flow of either a liquid or air flowing through a pipe. And this could be used in many different scenarios, many different types of factories, measuring water, measuring gas, measuring all kinds of things. It will just tell the system if something is flowing through and the rate in which it's flowing at. For example, if this was part of a system where water was constantly flowing through it, but all of a sudden it stopped, the flow sensor would pick this up, alert the system, play a sound, display a message, and again simply do something about it. Next up is an acoustic sensor, and again cluing in the name, acoustic means sound, and an acoustic sensor can pick up noise and once again do something as part of a system. An example I've not listed here is your phones or tablets, things like Hey Siri or Hello Google. Your phone has an acoustic sensor that picks this up and obviously gives you options to do with Siri or Google. But there are many other scenarios listed here, picking up noise levels in an alarm system, seeing how loud the noise levels are in a factory, but an acoustic sensor simply picks up sound. Gas sensor, as you can guess, checks for the levels of gas. Any type of gas that the sensor is set up to find, it will determine how much of this gas is in the air, and again it can alert the user whether the levels are too high or too low, but a gas sensor simply just detects gas in that environment. pH sensor will detect for pH levels in water. Many different scenarios this could be used, checking for pH levels in your pool, checking pollution levels in a river, checking acidity in soil. Many different examples this could be used, but again, clues in the name, looking for pH levels. And finally, we have a magnetic field sensor, which will detect for a magnetic field. And the go-to example I always give on this one is the compass on a phone. The compass on a phone works off a magnetic field sensor, and can determine which way your phone is pointing to tell you whether you're facing north, east, south or west. There are other examples as well, but the one I always go to for this one is a compass, as it's the easiest to remember. So that's all the sensors covered, guys. But what's important is that you can understand that you can apply a sensor to a scenario based on your knowledge of each type of sensor. There are many exam questions where you're presented with a scenario and you have to explain which sensor will be used and how it will be used as part of a bigger system. Something else that's very important when it comes to these systems is this term continuous feedback, because what sensors do is they're constantly monitoring for any of the conditions that we've mentioned. So for example, a moisture sensor is constantly checking for moisture in soil, for example. In an alarm system, if it's switched on, the infrared sensor is constantly checking to see if the light is broken. So the point is that continuous feedback is very important when it comes to sensors. Now what happens is, and I've mentioned briefly in the lesson, a microprocessor will be checking these levels again continuously based on some preset values that it's being programmed to check for. So an easy example to understand is the temperature sensor. In the car, it's constantly checking to see how hot it is. If that temperature reaches above 24 degrees, the air conditioning comes on to bring the temperature down. But again, it's continuously doing it to make sure the temperature doesn't reach above 24, 25 degrees. And all the scenarios that I've gone through in this lesson, this continuous feedback method applies to them all. I've mentioned alarms going off, warning messages displayed to humans, but as you can see in this bottom bullet point, the microprocessor is the device that does something about it. If the sensor picks something up, the processor will send the signal to the computer, to a speaker, but they are all part of a bigger system. So what I'd like to do, just to finish off, is go through a typical exam style question, and we have to determine which sensors would be used and to describe how the whole system would work using the keywords that I've mentioned in the lesson. The scenario we've got, it's an outdoor light, and it comes on when it's dark and if someone walks nearby. So the light makes use of two sensors here. As you can imagine, it's checking when it's dark enough and if someone walks past. So we have to determine which sensors will be used and describe how the whole system would work. So first and foremost, we need a sensor to check if it's dark enough, and that would be a light sensor. So a light sensor to check light levels and an infrared sensor to check if someone walks nearby. If the infrared sensor detects movement and the light sensor detects that it's dark, the microprocessor sends a signal to the light to switch it on. So that's a very basic answer to this question. If we were looking at full marks, because these questions tend to be 5-6 mark questions, what we'd need to do is we need to mention the two sensors, so the infrared sensor and the light sensor. We'd also need to mention this term analog to digital conversion, so that the sensor is doing this job. We mentioned that both sensors pick up some kind of movement or the light, keyword being and, they both have to pick it up. Then we'd mention about the microprocessor, which turns the light on. We'd also mention that the process is continuous, so the whole process is continuous. That would get you another mark. And what you could also do in this line here is mention some other suitable sensors that could be used and mention the problems that could exist with this type of sensor. So in our example, a proximity sensor could be used, but it could pick up small animals or even rubbish blowing in the wind. But again, guys, these questions are typically the same. They are the same format. The only thing that changes is the scenarios, and you just have to know which sensor to use and explain why. We've gone through a lot of different examples there. I hope they've all made sense. We will revisit some of this in a later unit when we look at automated systems, but as long as we've understand the basics of these sensors and how they are classed as input devices, that's what this lesson is all about. And this part of the syllabus in Unit 3, we can say we've covered. I hope you've enjoyed the video, and I will see you again in the next lesson where we will look at storage and how data is stored in the computer. Okay guys, thanks for watching. See you next time.